So it turns out, ladies and gentlemen, that there are other ways to prove that triangles are similar aside from angle, angle, and side, angle, side. So it turns out here that there's something that's known as side, side, side similarity, where you actually don't need to worry about any of the angles at all, as long as you have three pairs of corresponding sides in proportion here. So notice how in this situation we're going to start off with the fact that AB and XY are AB and XY, that ratio is the same thing as AC to XZ, which is the same thing as BC to YZ here. So our goal here is to show that with this, we can show that the two triangles here have to be similar to one another based on this thing here. So notice how the previous video we kind of alluded to the fact that side, angle, side actually worked by doing a little bit of an argument here. Here we're going to do the same thing, and I'm going to show you that side, side, side is actually a valid argument here by doing a little bit of finagling here. So I want to show that ABC and XYZ are similar. I don't know if they are, but I'm going to try. So what we're going to do here is we're going to control. So here's the thing. All we know at this point is side, angle, side, and angle, angle here. And angle, angle we're a lot more familiar with. So this is what I'm going to do. I'm going to create a new triangle here. So notice that I need to create something like this here. This angle B, I'm going to copy it down here. So this angle B, I'm copying down here. So these two green angles are congruent here. So angle ABC and angle ZY, I'll call this X prime. So we'll call it different. We'll call it W here. We want that to be the same, right? Similarly, I want this angle here to match this angle here. So what I'm going to do is I'm going to do something like this here, and I'll call this here W. So what we're going to do here is we're going to choose a point W under triangle XYZ so that angle ABC is congruent to angle ZYW, and angle ACB is congruent to angle YZW, right? So this is our little setup here. We're going to start off like this. Now, it should be, it does seem like these two triangles are reflections of each other. I don't know if they are. But if I can show that, then that's good, because I know that these two triangles are similar. If these are a reflection of each other, they should match. So that means I can take everything from here and put it up here, and that's going to be in good shape here. So the basic idea of this argument here is that we're going to show that by construction, these two triangles are similar, and these two triangles appear to be congruent. If I can show that, then I can kind of take all the angles from down here, move them up into my big triangle, and then therefore use angle, angle directly on the pair that we wanted. Okay, so by our construction here, we constructed two pairs of congruent corresponding angles. So that means it shouldn't be too hard to show that triangle ABC here should be similar to triangle, in this case, let's see, A matches with W, B matches with Y, and Z matches with C. So I can write it like this here. So this makes sense, right? We know that ABC and WYZ should be similar by angle, angle. So that's going to be important here. Now, because they're similar by angle, angle, well, let's see. That means the corresponding sides should be in proportion here. So I can write here the fact that AB, in this case, notice how AB corresponds with WY. So notice how AB and WY match up. And we know that this is going to be AC to WZ here. And that's going to be equal to BC to YZ. Okay? Right? These are corresponding sides in proportion. Okay. So this works out very nicely here. As you can see, this is our setup. Now wait a minute. Let's look at the given. There's another given piece of information here, and I kind of want to bring that down. So that other given piece of information is they have AB over XY equals AC over WZ. Sorry. AB over XY, AC over XZ, my apologies, equals BC over YZ. Interesting. Now let's analyze this here. Wait a minute. Notice that both of these have BC over YZ. They're all equal to this. Each of these four terms here are equal to that. Which, since they're equal to that, since these things are equal here, we can use the substitution policy and kind of substitute things together here. So that means here, one of the things that we can determine is that AB equals WY, this, and this. All four of these ratios here, AB over WY, AC over WZ, AB over XY, AC over XZ, they all have to match, right? Because they're all equal to the same thing. So that means I can take strategic pieces out of this. I can take some pieces out of this here. In particular, I can take that AB over WY equals AB over XY, right? Does everybody see that? I hope you see that here, right? Now, wait a minute. Well, let's see. This is a proportion here, so I should be able to cross multiply. So I get AB times XY equals AB times WY here. Well, I can divide both sides by AB because AB is a positive quantity, it's a side length. These go away, and we're left with XY equals WY here, right? Wait a minute. That means these two things have to match, right? So we've just shown that here. In addition, not only do we have, so these two lead to this. They also lead to, well, let's see, now we can match the other two. AC over WZ equals AC over XZ here. But wait a minute, again, the same idea occurs. We can do the cross multiplication, and we can show that WZ equals XZ here by doing exactly the same thing we did over here. We put it over here, and we show that WZ equals XZ here. Oh, wow. Wait a minute. So now notice, ladies and gentlemen, that I have just shown that XY is congruent to WY. I've just shown that XZ is congruent to WZ. Now, it's pretty clear that YZ is congruent to itself, right? So I've got myself congruent triangles here. Therefore, we can conclude the triangle XYZ here is congruent to triangle WYZ by side, side, side. This is our side, side, side congruence postulate, which we know about. Okay, so that's good, because now we know corresponding angles match. So this angle, WYZ, matches with this angle here, B. So these angles now match. These angles now match as well. But wait, that's what we wanted, right? Because now we have angle B matching with angle Y, we have angle C matching with angle Z, so now we can actually put everything together, and now these two triangles have to be similar by sides, by angle here. So in essence, what I've done here is I created this, dummy triangle on the bottom, show that this dummy triangle here has a lot of properties that we can use, and use those properties here to sort of transfer them into the triangle we really wanted. And that's what we have here. So this here, ladies and gentlemen, is another way to show that. So this here, shows that side, side, side here is perfectly valid and can be treated as such. So now we have three different methods of proving triangles similar. Angle, angle, side, 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 side. As a note here, ladies and gentlemen, remember that side, angle, side, and side, side, side here, these are actually a lot more uncommon. By and large, the majority, what you're going to do is to show that two triangles are similar is angle, angle. This is no, there's no question about that. You're going to be using that a lot. However, again, it's good to have these tools in your toolbox here because these can pop up, and sometimes angle, angle is a little bit stubborn. You can't do anything about it. You can use side, 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 or side, angle, side when that case turns up.